Hi everyone, hello, hello. Hi everyone, hello. Hi. Let us just wait for another. First, our first poll is okay. Okay. Alright, so can anyone tell me what is motion in the chat? Anyone? Like, what is motion? Like, what you learned about it? Yeah, that is correct. Yes. Change in position, yes. What else? What causes motion? Okay, we have our first point. Motion is a change in position of an object, right? Correct? Fine. What else? What causes motion? Like anything else that causes motion? Like what causes motion? Is there anything hmm, okay, is there anything external which causes motion? Like it causes the body to move? Simple, like it's a force. It's either force, um, it's either force or any energy that's being generated inside the body, right? Example, in a car, you use electrical energy which gets converted to mechanical energy, most probably yes. Electrical energy which gets converted to mechanical energy, and then you use it to run the car moves because of this, right? Alright. So, from both of these points, you see that motion is anything like causing due to any force or energy force applied on an object which causes it to move. This results in motion. Alright, now let me give you a fill in the blank. Motion is dash. Okay? Motion is dash. Motion is. There are many answers for this, but there is a really obvious answer. Alright? There is a really obvious answer, which is which is no, I'm saying motion is what? I'm not saying motion is change in position or that. You already told me that. No, I'm asking motion is dash. I gave you a fill in the blank here. Motion is dash. There's a really obvious answer. Like, I'll give you a story for this. Then you'll easily tell me the answer. See, you're inside a bus. You are sitting next to your father. No, with respect to you, your father will be at rest, right? You won't see your father as moving because he's sitting next to you. Similarly, when you look at a person who's standing, like your friend or someone who's waving to you outside the window, you would see him as moving as the bus is moving. Huh? As the bus is moving, you see him moving and you go. Okay? Fine. Is that correct? Yes, you agree with me? Okay? Yeah. So, what do you call this? Motion is. See, with respect to you, friend is at rest. No. Yeah, of course the friend is at rest. But let's say you are looking at your friend. No, I'm saying you're inside a bus, okay? This is you. Imagine this is you. You're looking at your friend who's standing outside. The bus started moving. How will your friend be? Like, with respect to you, would your friend be at rest or would your friend be at moving? Be moving. Okay, I'll just answer this question. See, you know, the bus moves. Your friend keeps on disappearing, no? Your friend disappears. No? Even though you know that your friend isn't moving, with respect to you, he appears that he is moving, he is going backwards. Similarly, in a train, when you look at the trees are going backwards, they appear to be moving. That's simple. Now, the same thing is for your friend. Your friend, when he looks at you, like you feel like you're moving. When the bus starts moving, you feel like you are moving. So, motion is relative. Okay? Motion is relative. Fine. Okay. Simple. So, this shows that. Okay, you understood? Yes, great. See, an object that is inside a moving body will appear to be in motion, even though the body isn't moving. This feels confusing, I really know that. But then the meaning is simple. It's that even though a body who is sitting inside a moving body, a moving object like a car, even though let's say a human is sitting inside the car, the human is at rest. He's sitting. He is not moving. But when the car starts moving, the human also appears to be moving to an observer outside. You're having an exam tomorrow? Okay. Fine. Determine motion even though the body isn't moving. I mean, this is also rapid revision, of course. And that too, most probably we might do graphs. Okay? We will most probably do graphs. Even though the body isn't moving. Okay? So this shows that motion is relative. Next one. After that, when a body is moving, you notice that it's traveling at a certain speed. What is speed? First, to understand speed, we need to understand about distance. Let's say you have your toy Hot Wheels car that you play every day. Fine. You will notice that the car will be traveling at a certain speed. You push it, the car moves. Let's say you place a scale here, okay, and then it feels like when you look at from a distance, the car is above the scale. You notice that the car starts moving when it starts from 0 and it stops somewhere. Let's say it stops at 5. Okay, we'll say it stops at 5. This length, which is 5 centimeter, is the distance traveled by the car. That is the length. Now, let's say you also keep a stopwatch with you. Fine, you have a stopwatch and measure this time. Fine, that is the time taken by this car to cover the distance. Now, when you divide this distance by time. What do you get? What do you get when you what do you get when you divide distance by time? Answers. What do you get when you divide distance by time? Yeah, distance divided by time. What do you get when you divide distance by time? Yes. What do you get when you do this? You get speed. So, speed is the rate at which an object travels a certain distance within a given period of time. Alright, that is called the speed. SI unit of speed is meter per second, because what is the SI unit of length slash distance? It is meter. Time is second. Meter per second. Simple. Understood? Now let's solve the question. Find an object travels 500 kilometers in 4 hours. Of course, it's too small. In 10 hours. Okay. Alright. How much? Sorry. What is the speed? Alright. What is the speed? What is the speed? Speed is, see, what is speed? What is the formula for speed? Speed is equals to distance by time. What is the distance? 500 kilometers. 500. What is the time? 10 hours. Cancel these two. His speed is 50 kilometers per hour. Hello. Hi. Hi. Hello. So his speed is 50 kilometers per hour. Fine. This was easy. Still not very easy. Now let us move on to, first, before we learn about the displacement and all, we need to learn about the types of quantities. How many types of quantities do we have? Not those physical and derived quantities, I'm talking about in physics. Like in motion. What are the two types of quantities we have? What are the two types of quantities we have? Quantities, there are two types: scalar quantity and vector quantity. Okay, scalar quantities, they don't need magnitude. Like to represent them. Vector quantities, however, they don't need direction. Sorry, oops, they don't need direction. Vector quantities, they need, oops, they need both magnitude and direction. All right, they need both. They need both magnitude and direction. Simple, easy. What are examples of scalar quantities? Distance, speed, etc. What is an example of vector quantity? A vector quantity examples are, we have force, then we have velocity, then we have displacement, and many more. Okay, I will explain you vector quantities right now. Fine. You are okay. You are in your 8th grade. Fine. Let's say you are an 8th grader. You have a body. Okay. You are applying certain amount of force on it. Fine. Let's say the SI unit of force is Newton. Newton is the SI unit of force. But I'm not discussing about force now, so don't go deep into it. We'll discuss it when we talk about force and laws of motion. Fine. Now, when you look here, see, you, let's say you're A and the other person is B. Okay, first I'll take this. Okay, you're A, you're B. You apply 20 Newton of force, B applies 10 Newton of force. What is the net force? Okay, what is the net force? Okay. Answer the following poll. Alright, what is the poll? Sorry, what is the answer? What is the answer for the following poll? See, I have the question here. I'll zoom in and give you yours. So, answer the poll. What is the net force? I'll give you a time of 10 seconds. Okay, and then I'll end the poll. Okay, fine. See, what did you learn when you were in 8th grade? When two forces are applied in the same direction, what do they do? What do they do? Huh? They 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 add up. Simple, easy. They add up. So 20 plus 10 is equal to 30 Newton is the total force. Fine. The total force is 30 Newton. Now, let's say I'll cancel this out. Yeah, this one. Now what is the net force? Bolo, tell me now what is the net force? Now, see, simple. Guys, answer. This is your 8th grade. You need to know this and not understand quantities. Scalar or vector. Without answering, if you sit like a lazy man, what are you supposed to do? How are you supposed to answer? Tell me that. See, here direction is important. Why? Look at the change. Here both of them are acting in the same direction. Here both of them are acting in opposite directions. Now, what is the net force in this case? Net force, I'll name this A and B. Which is equal to A minus B. Because A is larger than B. No? Which is equal to 20 minus 10. What is 20 minus 10? At least tell me that. It is 10 Newton. Simple. Okay? Now, after we finish net force, we see here direction was important. Let's say we didn't know what was the direction, how are we supposed to calculate the net force? Tell me, is there any way to calculate the net force when the direction isn't there? Pranav, come on. If you don't have the net force, is there any way to, if you don't have the direction, is there any way to calculate the net force? No, simple, that's why your vector that direction is important for vector quantities. Fine. Okay, now let us move on to displacement. Now, let's say I imagine myself. Fine. Okay. Fine, I imagine myself, this is A, myself, me. I am going to my school like this. Okay? See, this is a circle. Fine? This is A. My school is here. Let's say I name this point B. Tell me how much distance I'm supposed to cover to get to B. Huh? Hey yaar, my energy level is going down, no one's answering. See, I'm asking you, let's say this is me, A. This is my school B. I had to go from A to B. Okay? Fine. I have to go from A to B. I go this way, like this. Okay? I have to go to B. Now, what is the distance I'm supposed to cover to get to B from A? What distance am I covering? Are you guys okay? See, you guys are good at maths, no? Like at least good. You remember formulas, no? Now what is the distance I cover? Hint. It is this circumference. Okay, I'll highlight it in a different color. Okay. It is this circumference. What is the circumference? See, what is the perimeter of slash circumference of semicircle? It is perimeter of semicircle. It is perimeter. What is perimeter of a semicircle? It is 2 pi r, which is the perimeter of a circle, by 2, which is equal to pi r. Okay. Here you have to include without diameter. Okay. There's no diameter in this. So perimeter would be here. The distance would be pi r. Now, let's say if you are a topper, you are my topper, you are my teacher, you are my idol. What route would you take to cover the shortest distance and so that you won't get tired to go from A to B? Huh? Sorry guys. What distance would you cover when you have to go from A to B? Tell me. It is the diameter. Arey bhai, so easy, no? But then why didn't you tell me the answer? See, R, this is pi r, this is 2r. Pi r is greater than 2r, no? So, this is called the displacement. Okay, what is displacement? Shortest distance from the initial position to the final position. Okay, fine. Got it, everyone? Everybody in the chat, come on. The Josh meter should be high. Okay? To the final pitch. Fine? You're coming here till now, so clap hands for yourselves. Okay? It is the shortest difference from the initial position to the final position. Alright? Okay. Now, there are differences between distance and displacement, right? Distance is the longest distance. Whatever distance you did, the time path you took, then displacement is the shortest distance. Then, displacement bro, listen. Now, when you're traveling in this path, okay, is your direction remaining the same throughout this entire journey? Tell me. Seriously, tell me. Is your direction the same throughout the entire journey? No. No. The direction here is here. While here it's just this east. Let's say this is not there. Okay. So displacement depends upon direction. When it depends upon direction, what is it? I explained for you for around 15 minutes. No, that thing, force and net force. What is it? What quantity is displacement? Scalar or vector? If anybody says scalar in the chat, you know, um, when I spent around 15 minutes for it. Okay, just to explain you what is a vector quantity. Displacement is a vector quantity. Alright, displacement is a vector quantity. Fine, understood? Now I'll give you a question. Next question. Arey, some dude in the chat told me he has his exam tomorrow. Who is he? That dude was asking me. Distance divided by time is time. Good luck for your exam, bhaiya. Okay? Question. Alright, now. Okay, now here. A particle moves along the path A to C like this. Find the distance and the displacement. बोलो बोल लीजिए सर. Find the distance and the displacement. Okay, fine. Fine. No one's answering here. We have A to B, B to C. What is this? 15 plus 8, which is 23 centimeter. Masadi Sai Harshit, hello. Okay, so the distance is equals to 23 centimeter. Fine. Now, what is the displacement? Everybody in the chat here, find it. What is the displacement? Find the displacement, or I'll just go and drink some water. 17. Yes, that's correct. Masadi Shai Arshita, you are correct. Finally, I got one person who concentrates. You are correct because applying the Pythagorean theorem. And how 17? Tell me. How do you know it's 17? How is it the shortest distance? How will you provide? Simple. There is this thing called triangle inequality theorem. Fine. It shows that the sum of two sides should be greater than the third side. What is 15 plus 8? 23 centimeter. Is 23 greater than 17? Yes, of course. So it means 17 is the displacement. That is correct. You're great. Uh, you're great. Fine. Let's move on. Okay. Fine. So from this, you found out that the displacement is 17. Okay. Fine. Got it? Yes. So let's say no. Before I was telling you, first we'll learn about the formula for displacement. What is the formula for displacement? It works sometimes. I mean, most of the time it works, but sometimes it's a little hard. It is the final position minus the initial position. Okay. Fine. Got it. Got it, guys. Simple. Yes. Now, before I was telling, now another thing is that displacement depends upon the path, while distance does not depend upon the path. See, and this is related to another point, saying the displacement can be 0, positive, and negative, or sometimes equal to the displacement. Okay? Sorry, distance. Okay? Now, tell me, somebody in the chat explain me, how can displacement be 0? Okay? Just asking you. I can explain, but I'm just asking so that we can be interactive. How can the displacement be 0? Huh? How can the displacement be 0? Is how can the displacement be 0? Masadi, Harshit, okay, I'll call you Harshit. You can say the answer if you know it. Okay, now keep aside all of this, I'll just explain it. How can it be 0? Now what is displacement? Displacement is equals to final position minus initial position. Distance the final position, distance the initial. Okay, fine. Got it? No? Yes? Okay. That is correct. No, I mean, okay, see. When it ends at its starting point, yes, that is correct. How? 1 minute.
Thank you.
Okay, so when the displacement, when it ends at its starting point, that is a fair answer. How? Anybody tell me? See, because let's say this is me being a stupid dude. I start from here, I go a circle and I end up there. See, if I take, let's say this is a circle, okay? I make a beautiful circle. Yes, beautiful circle, mission accomplished. I move around, okay? I'll go around, and come here. Now, what is the distance? Distance will be the circumference of the circle, which is 2 pi r. No? Correct? Then tell me, Charan Bhaiya, what will be the displacement? Displacement is equal to d of f minus dii, no? Starting position minus final position minus initial position. which is, so here final position and initial position are the same. So then what will be the answer? It is 0. Then now how will the displacement be negative? Fine, let's say this is me. Okay, A, B. Okay, this is 0. This point is 0. This is 20. Okay. Then see, first we'll go till from A to B, which is 20. Here distance and displacement is the same thing. As long as you move in the straight line, the distance and displacement is always the same. Only when you change your direction and curve around, the displacement will change. Soon as you change your direction, displacement will change. Okay, so I go from A to B. Okay, 20 to, then I again come back 10, then I reach the point here 10. Fine, so I have traveled 20 kilometers, then I will come back 10 kilometers. This is here will be negative or not, because final position is lesser than initial position. It is of course supposed to be negative. It won't be positive. So 10 minus 20, it's minus 20 is the displacement. Okay, fine. Now I have a question for you, a complete theoretical question, no numericals involved. Fine. Okay. Alright. Can an object for me, I'm from India, but I can't tell where, okay? I mean, see, you of course would know, depending on the places we have filmed. Fine, see, can an object, 1 minute, wait, there's something here, there's an error. One minute, guys. There is an error here. Okay. Okay, fine. Yes. So my name is Sri Charan. Basically, even I am a dude who's studying 9th grade, and I'm learning and trying to help you all in this. Fine, but then I'm also trying to learn concepts from other grades to help you all. Is that enough? Okay, the question is, can an object traveling from point A to point B in a curved line have its distance less than its displacement? Yeah, I am 9. Yes, I am 9. So, can an object traveling from point A to point B have its distance less than its display in a curved line? Like, okay, let me tell you. This is point A, this is point B. This is the way it's traveling. Okay, can it have hello unit new NCERT नहीं है भाई, old NCERT है, 9th grade motion, I believe unit 1 year. Okay. Can an object traveling from point A to point B in a curved line have its distance less come, then it's displacement. Answer this question. Okay, I'll put it as a poll so you can answer it much better. So then instead of typing an object traveling in a car line from A to B, how its distance is then its displacement. Okay? Answer this question. And then tell me the answer. Fine? Like you don't even tell me the answer, you just answer the poll. Okay? No. Okay? So we have one vote. I believe it's Harshit again. Yes. Arey yaar. See, whatever distance you cover, displacement is basically the shortest distance. Fine? So when you're traveling in a straight line, displacement and distance are equal. But there is no possibility where the distance can be less than its displacement. Alright? Okay? Fine? Yes? No. See, there is no way that the distance is less than its displacement. Okay? Now, let's move on. We have velocity. So, first of all, can all of you tell me what is speed? What is speed? What is speed equals to? What is speed? What is speed? Speed is equals to distance by time, right? Everybody knows this, no? Right? Everybody knows this? Yes. Similarly, velocity is speed with direction. It is speed, but it has direction with it. So it is basically not equal to speed all the time. Unless, like displacement, the object moves in a straight line. That too with a uniform motion. I'll explain what is uniform, non-uniform motion later. Fine. Velocity equals to displacement. Displacement by time. Okay? Got it, everybody? Got it? Velocity is equals to displacement by time. Now, what is the formula for average speed? Average speed formula, which I didn't tell you before, is the total distance traveled divided by the total time taken. Got it? So, similarly, in the same way, average velocity is completely different. Okay? Average velocity is final velocity or maybe initial velocity because it's addition. Initial velocity plus final velocity by 2. Okay? Got it, everyone here? Average velocity is initial velocity plus final velocity by 2. Alright? Alright. Now, how do you represent this? VAV, which is average velocity. This is okay. is initial velocity. How do you represent initial velocity? With u plus final velocity, which is v by 2. Simple, easy. What is SI unit of velocity? SI unit of velocity is the same unit as speed, meter per second, or meter as ms to the power of minus. Same, both of them. Then you also have kilometer per hour. Now, after you have finished all of this, you have differences between. It's the same thing, like it depends upon the path and all. It's a scalar quantity. Velocity is a vector quantity, and then the velocity can be negative and all. However, this is only positive. Speed is only positive. Now, next point. Okay, fine. Velocity can be negative. See. Okay. Now, let's move on to change in velocity. This change in velocity is referred to. What is the change in velocity referred to? You ask your dad to press it. No, like not in that. Like you stamp it like in your car so that you can go fast. Daddy, overtake this car. Daddy, overtake that car. Daddy, overtake that Ferrari. Daddy, overtake that Lamborghini. What is it called? What is that thing that you press on called? What is that pedal called? Come on. What is that pedal that you ask your dad to press on when you're going on for a vacation? Either somewhere nearby or somewhere on a highway, you ask your daddy to press overtake this car, overtake that car. No, what is it? What is that pedal called? Huh? What is that pedal called? Come on. Even I ask this, okay? I am among one of you. Mera dost. I am one of you. You ask your dad to press this, no? Stamp it. Exit speed of 100. What do you ask? What is it? Come on, guys. Arey yaar. Harshit, come on. In the car, what is it? Arey yaar. No. Come on. Accelerator. Wow. Accelerator. What is the accelerator? You kick it, it'll go somewhere. Simple. So that is what this change in velocity is called acceleration. That is why they named this accelerator, because accelerator causes change in velocity or speed when you're going on a highway. Because let's say you are pressing the accelerator, like you're just touching it. It is going at 20 km/h. Suddenly you see some, you want to go fast. The road is fully empty. You want to go fast. You're like, Daddy, go fast. Daddy, what is this, Daddy? You are not acting Gen Z, Daddy. Like, your daddy gets angry on. He wants to show his strength and all. Huh? He wants to show his strength. So, and then he presses the accelerator. Suddenly, your car goes up to speeds of 100 km/h, 150 something. Don't make your dad angry, nah. If you make your dad angry, that's all. He'll make you reach Kanyakumari. He'll make you go from Kanyakumari to Jammu Kashmir in 5 hours. 100 kmph. See, I'm talking about when velocity is in straight line. Okay? I'm talking about straight line, that's right. See, so, now, what is the change in velocity? Like how much the velocity increased? 20 80 kilometer per hour. It increases by 80 kilometer per hour. Okay, it increases by 80 kilometer. Now, to find like how much it accelerated, you divide it by the time. Let's say he did it in 5 seconds. He got very angry. He did it in 5. Then it's gonna be a contradiction. No, I don't want to make you confused about units right now. First wait. Ah, okay. I'll say 1 by 2 hour. 1 by 2 hour is too bad. 1 by 4 hour. Okay. So 80 by 1 by 4, which is 80 into 4 by 1, which is which is 320 kilometer per hour square. Okay, fine. That is your acceleration. So what is acceleration? Final velocity minus initial velocity by the time taken. Okay, got it everyone? Simple, easy, good. Okay, fine. Now let's just check some. Now, alright, we got all of this. Now we are going to be doing questions. Fine. Question number 1. Okay. Based on from displacement till now, because we didn't do questions in if the okay if the final and initial traveling if the displacement is equal to 5 meters and time is 5 seconds, find the velocity. Find the no one's starting from here, okay. What do you want me to do about it? What do you want me to do about it? Tell me. Actually, see, you said something like saying that no one's turning from here. All right. Okay. So you're basically trying to tell me, okay, no one's turning from here. You believe that I'm going to stop the video or something? Just tell me for a second. You're saying no one's turning from here. You believe that I'm going to stop the video or something and say, oh no one's turning from here. Shall I stop the video? I didn't get it. Tell me that. Actually. Not trying to be, just asking you a question. So like, are you feeling that I'm going to stop this video? No. Because it's basically not teaching for views. No, I won't. Whatever, did you you want to learn? I'm just asking you. Let me just continue with this. I don't want to waste the time now because especially when it's 9:03. So, if the displacement is 5 meters and the time taken for it to cover that displacement is 5 seconds, tell me the velocity. Find the velocity and tell me. Okay? Find the velocity and tell me. Yeah, so the velocity is displacement by time, right? Which is equals to 5 by 5, which is how much? 1 meter per second. That is your velocity. Fine. Okay. Second question. The next question. What is the next question? It's no. If the initial velocity u is equals to 5 meter per second. You're the only mirror here. No. I don't think so. No. No, I'm just asking you, have you come here to learn normally? Like what grade you're in. That's what. Bye. Okay. If the initial velocity is equal to kitna? 5 meters. Fine. It is 5 meters per second. Got it, everyone? Now, the final velocity I'll give you as okay. Mm-hmm. I'll give you the final velocity as 10 meters per second. Fine. The time taken for it to increase that speed from 5 meters per second to 10 meters, velocity from 5 meters per second to 10 meters per second, what is it? The time is equals to 2 seconds. Find the acceleration. Find the acceleration. Okay? Find the acceleration. All right. All right. Okay. Acceleration. What is acceleration? Simple. Acceleration. So, the acceleration, what is acceleration? Tell me guys. Tell me. Tell me the acceleration guys. Okay. Acceleration. What is acceleration? What is acceleration? Acceleration is equals to v minus u by t. Okay, what is v? 10 minus 5 by 2. 5 by 2 m per second square. Okay. Simple, this is pretty simple games, okay? Now, one more question and we'll move on to the equations of motion, which is our most important, most feared topic. Fine, okay? Now, next question. Okay? The energy is 5 by 2 meter per second and all, no? Question. If the acceleration is 10 meter per second, no, 2 meter per second square, v is equals to 0, fine, time is equals to 4 seconds, 0. Find the initial velocity. Okay, fine. This question will make you understand. This question will make you understand about the equations of motion before. Fine. Oh, there are 2 people who are watching the video. Okay. Okay. Now, find the initial velocity. The acceleration is v minus u by t. Find v is 0. 0 minus u by t is 4 and acceleration is 2. 0 minus u is equals to 4 times 2. 0 minus u is equals to 8. Fine. Now, here you can easily derive the equation of motion. V minus u, this is V now, this is u now, is equals to, what is this product? A times t, acceleration times t. Here. This gives you the first equation of motion, v equals to u plus at. You take this to decide a t plus u or u plus at. Here v equals to u plus at. This is the first equation of motion. Simple, guys. Okay. V equals to u plus at is our first equation. So then you can apply this here. You just solve this. U minus u equals to 8. 0 minus 8 is equals to u minus 8 is equals to u. Simple. Got it, everyone? Bola. Okay. Yes. Fine. Now, so let us go to our favorite equations of motion. Okay, equation of motion, there are three equations. One is v minus, okay, so v equals to u plus at. So, okay, got it. Then s is equals to ut plus 1 by 2 at square. Fine. Then we have v square is equal to u square plus 2as. Okay, these three equations of motion you memorize them. It's pretty easy. I already derived the first equation of motion for you. Second one is, see, acceleration is equal to v minus u. You got the first one. Then velocity equals to this. See, here you have initial, final. Okay, see, Prashant Bhaiya, our Prashant Bhaiya, next stopper Prashant Bhaiya, he derived one way. He is one great person. I'm telling you, he is one great educator. Learn from him, you will get everything correct. I'm telling you. Okay, you'll score good marks in your exam. Even I was thinking motion was hard. Okay, I was thinking basically that so basically okay. Okay, yeah. So v square is equal to u square plus 2x. Let's do some questions. Let's say an object is traveling at final velocity. The object, see, is traveling and then it came to rest. Fine. Okay. Then it has a constant acceleration of 2 meters per second square. Then, okay, t. The time taken is 4 seconds. Find the initial velocity. Simple. Here, use the equation v equals to u plus at. 0 is equals to u plus 8. 0 minus 8 is equals to u is equals to minus 8. Simple. Minus 8 meter per second. How 0 u plus 8 you substitute करो आऊँगा ना Papala. Fine. Now, second question. Here u initial velocity is equals to 4 meter per second. Here final velocity is equals to 30 meter per second. Time is equals to 4 seconds. Let's change the time. How can I increase the distance? Okay, 12 seconds. Find the acceleration. Again, v equals to u plus 8d. So v is 30. 30 is equals to 4 plus 12a. 30 minus 4 is equals to 12a. 12a is equals to 26. A is equals to 26 by 12. That's all. 13 by 6 meter per second. Okay? Fine. Meter per second square. Sorry. Okay. Now, see, there is another type of question in this called free fall questions. What are free fall questions? Let's say you throw an object from the top of the terrace. Huh? The top means the terrace. What are you saying? From the top of the terrace. That is, say like from the terrace you throw it. You notice that it falls down. Or let's say you throw an object up, it goes up. Initial velocity, let's say initial velocity 20. Final velocity 0, no? It goes up, it will stop. Time taken. Acceleration. Here, how do you know what is it? That is what people have found as small. What is small g? Which is 9.8 meter per second square. What is 9.8 meter per second square? You use it as 10. Only in other higher classes you use it. Only in higher classes you use it as. Only in higher classes you use it as 10 meter per second. Okay. Fine. Alright. Okay. Now, use the equation v equals to u plus 80. 0 is equals to, you find the time easily. Initial velocity 20 plus a, acceleration is, you substitute g. 10 0 minus 20 is equal to 10a. So then here minus 20 is equals to 10a, a equals to minus 2. I mean the time. अरे यार क्या हुआ? minus 10, sorry. Oh no, minus 10 t. 20 minus 0 is equals to 10t. 20 equals to 10t, t is equals to 2. No, t is equals to 2, no. Tell me. T is equals to 2, no. No. Find the height. They ask you. Height कितना होता है? Basically, you use v square minus u square equals to 2as by v square minus u square. v कितना है? v कितना है भैया? 0. 0 minus u कितना है? 20. 400 is equals to 2as. Acceleration minus 10. No, equals to minus 20s. Minus 400 is equals to minus 20s. S is equals to minus 400 by minus 20. अरे S is equals to 20. अरे यार 20 meters. Wow, 20 meters सही जा रहा है. Wow, maybe it was a very light object. Okay, distance time graph. Simple, rapid revision. Slope represents speed. Displacement time graph. Slope represents velocity. Just kidding, no. Velocity time graph. Displacement time graph is also there, but it's not common. Velocity time. area of slope represents कितना area of slope represents displacement. Slope represents area under the slope represents displacement. Slope represents acceleration. No. And then slope area only ignoring minuses represents distance. Okay. See. Now this, let's say our body is traveling like this. Okay. This is 40 mark. Okay. Its velocity, it means that it's not at rest. It means that the object is traveling at 40 meter per second constant velocity. So acceleration is equal to 0. Then this represents time. Then this goes minus 2 minus 2. Okay. See velocity time graphs can go like this. But remember this area hota hai na. This area and this area together sum up. You have this is A1, this is A2. Okay, this A1, A2, A1 plus A2 ignoring the minuses, you get distance. Okay, A1 plus A2 with minuses, you get distance. Simple guys. Chapter ho gaya, finished. And then nahi, you have uniform. See, in uniform circular motion, there is nothing basically. Remember this. Velocity is equal to displacement by time. What? See, in that circle, we know that circle, no? We are talking about that circle one. Circle question. Circle wala question. Huh? Circle wala question. Okay? There the displacement was 2r. Then velocity will be displacement by time 2r by t. No? Then speed is easy. Speed is distance which is 2 pi r by time. Simple. Ho gaya. Chapter ho gaya. Thank you guys for watching. See you next time, next video. Bye bye.